So in mini-batch gradient descent, what you do is you take the best of the both. The best of stochastic gradient descent and the best of batch gradient descent. So you don't take all of your samples at once like you do in batch gradient descent, and you don't take one sample at a time like you do in stochastic gradient descent. What you do is you take a batch of samples, feed it to the network, calculate the error, update the weights. Alright? So each batch will contain a specific number of samples, and that's called the batch size. Alright? So let's read it here. We perform weight updates for a batch of samples. So we take n training samples, which is the batch size, and then we feed it to the network, calculate the loss, update the weights. So in this case, the number of iterations equals to the samples, your whole samples that you have, the complete data set, divided by the batch size. So each batch will contain a specific number of samples, and then you're feeding this batch to the network, calculating the loss, updating the weights. Alright, so in order to calculate the number of iterations that you need to divide by the batch size. You need to divide the samples, all of your samples, by the batch size. So this is how it's mathematically represented. Okay, now previously we saw that for each sample we need to perform the weight update, but now it's for each batch. So for each batch we're going to perform the weight update, and it's the same, the old weight minus the learning rate times the differentiation of the error with respect to the weight. Okay, and this loss function is calculated for each batch. So if we take a look at the example that we usually visualize, then this is what we have. This is your complete data set. So in this case, we're going to take a batch of 4. That means each batch contains 4 samples. We're going to feed these 4 samples to the network, calculate the error, update the weights, alright? And then we're going to take the next batch, which is the next 4 samples, feed them to the network, calculate the error, update the weights. Alright, so we're going to take a batch of samples, feed them to the network, calculate the error based on the batch of samples that we feed it to the network, and then update the weights. Alright, so our loss function here is based on the batch of samples.